Okay, so if you're working on your homework, there's going to be a couple of those problems in there. And the problem is, let me just show you the problem. And I want to go over it again because, like I said, some people didn't get it, and that's fine. But let's see. This may be one right here. Well, there it is. And those of you that can see the board, I can't see your board, so I don't know if it's a good. They ask you to pick 2 points. See? And that's where people are getting confused. And that's why I'm going to go over this again. So let's use these points right here. And I'm going to let you write them down. And I'm going to write them down also. X, and this is observed, and observed Y. In other words, these are the actual points. Okay, there's that feedback again. I don't know, but I guess it just starts. 30, 40, 50, 60, 70, and 91, 87, 83, 74, and 62. Now, there's 2 lines, there's 2 equations that they want you to find. There's 2 equations that they want you to find. One, they want you to find the line of regression. And this is like part C and D. C, comma, D. B, they want you to find a line using 2 points. And that's what's throwing everybody off. Okay. So B, they're asking you to use 2 points, and let's find those 2 points. I don't know why it started feedbacking after he left, but that's normal. Trying to find the question. Where's the question? There it is. And they're wanting to use 40, 87, and 70, 62. So here are the 2 questions that they're wanting to do. They're wanting you to find a line of regression. Then you can find the residuals for that. Then first they want you to find the slope and the equation for these 2, and find the residuals with these points. So I'm going to break it up into 2 problems. Okay? I'm going to break it up into 2 problems, and I hope you can follow along with me because, like I said, the way they have this written, it's kind of confusing. So I'm going to take this to the Excel spreadsheet. And blow it up where everybody can see everything. All right, there's our points. And 40 and 87, I'm going to highlight that one. And 70 and 62, I'm going to highlight that. And I'm going to go over here. I'm going to go down here, and I'm going to find the slope of that line. M is equal to, equals parentheses, y sub 2 minus y sub 1 divided by parentheses x sub 2 minus x sub 1. I want somebody to check my math there and check to see if you get a slope of negative 0.8. Somebody check that for me. I'll put it on the whiteboard here. And let's check it. This is x sub 1, y sub 1. This is x sub 2, 2. So M is equal to 62 minus 87 divided by 70 minus 40. And 70 minus 40 is 30. There's that dang noise. And 62 minus 87, well, 87 minus 62 is 25. 7 minus 2 is 5. And let's see, 8 minus 2, 25. So negative, and that's negative 1. Let's see, 5 will go in there, 5, 6. And it's 5, 6.8, isn't 5, 6 divided, isn't that 0.8?
0.8, 3 repeating, but yeah, you're welcome.
0.8. And now we're going to use this point. So y minus 87 is equal to negative 0.8 times x minus 40. Y minus 87 is equal to negative 0.8x plus 0.8 times 40. And I'm just going to do this on the computer. I'm not going to try to use a calculator. So I'm going to go down here. I'm going to make this a little bit longer. And let's go with y is equal to negative 0.8 x plus parentheses 0.8 times 40 parentheses plus 87. Y'all check my math, please. And it didn't like it. So let me do it over here. Hold on a second. I'm going to have to do this separately. Copy 0.8x 0.8x and then equals Control V. I got 119. Somebody check my math and see if that's what y'all got.
Yes, sir.
So y is equal to negative 0.8x. Y is equal to negative 0.8x plus 119. Okay, now what are you supposed to do with that? B wants you to find the line using 2 points. We found the line. Now what do you do with it? Well, now you got to figure your points. Okay, right now, and I'm going to try to do this with your calculator. I'm going to try to do it. Here's your calculator. And we're going to clear this. And we're going to clear this. And I'm going to clear all of them because I've got too many numbers. Clear this one. And clear this one. All right, now I'm going to punch those numbers in. 30, 50, 60, and 70. And now I'm going to type in 91, 87, 83, 74, 62. Now, I'm going to draw this with the Excel spreadsheet. With the calculator. And I'm going to, first of all, plot, stat plot, on, goes, it's already reading everything, so just hit graph. Let me take that out. Y is equal. Hold on a second. Let me take that out. That was from calculus. All right, so graph and hit zoom, stat. There's your points. Now I'm going to put in my equation right here. I'm going to put that in. Y is equal to negative 0.833, negative 0.8333x plus 119. Graph. Okay, that's using those 2 points. Now, I'm going to take my handy dandy line maker or dot maker, and I'm going to put a point right here. Wait a minute, let me make it a little bit bigger. Now, I'm explaining this bit by bit because, like I said, some people didn't understand it. There's a point, there's a point, there's a point, there's a point, and there's a point. And we're using our observed points. Blue points are observed. So let me go back to the Excel spreadsheet. The blue points are observed. So I'm going to highlight these blue. Okay. The red points, which we just calculated, or the line that we just calculated, those are and I'm going to put those right here. Those are called our predicted points. Okay, equals negative 0.8 times x parentheses plus 119. And those are our predicted points, which I will color them magenta, just like those little dots. So let me pull the calculator back up. Those dots right there are the dots represented by these points right here. Now, can anybody remember what Y hat is, or what the residual is? What is the residual? Anybody know what the residual is?
It was the distance between your point and the yeah.
The residual is the difference between the 2 points, the predicted and the actual, right?
Yep.
Residual. So I'm going back to my calculator, and I'm going to take my yellow line right here. And it's not going to cooperate with me, but we got to find that yellow line. We got to find the distance of that yellow line. And that's called the residual. So we go back to the Excel spreadsheet. Now I want to know why that feedback wasn't happening when that guy was in here. Figures. Yellow. And that is, and write this down, the residual is the observed value, which is 91, minus the predicted value. So each one of these yellow lines, that's -4. That's 0 units. That's 4 units. That's 3 units. And that's -1 unit. And what do they want on B? They want the sum of the residual squared. Sum of residual squared. You're going to have to take that -4 and raise it to the second power and do that. And then add them all up. And that's the number your homework wants. So I'm going to put that in green because for some reason, I really don't care because I don't want you to have to do the residuals, but that's what they're wanting. They may ask you for just the residual. Okay, the sum of the residuals, but this is the sum of the residuals squared. Now that's how you do, and you have to do it kind of by hand and with the calculator because the Excel spreadsheet, it's hard to do the 2 points with the Excel spreadsheet. Any questions so far? Okay, now let's do the actual, this right here. Let's do the line of regression. Let's do the line of regression now.
Pull it in, push down, pull up.
So the line of regression, I'm not going to do that by hand. I'm going to do that with the Excel spreadsheet.
It's time to tough it out today. I'm trying to work on it right now.
What?
Nothing.
Nothing. Okay.
It's Mr. Gray.
Okay. So I'm going to do a line of regression. I'm going to start it over. I'm going to copy this. Control C. I'm going to go Control C. I'm going to go down here. I'm just going to redo it right there. And I'm going to draw a line of regression. So I'm going to go to Insert. There is your line. and I'm going to right click and add trend line and display and display. Now, somebody tell me, what do you think? Oh, that's annoying. What do you think is more accurate? Using 5 points or using 2 points?
5.
Using 5 points. And that's what they're trying to get you to see. That's the only reason I think they're doing this, is because, I don't know, maybe you can see it better. I don't know. And that's why they're getting you to do the residual. So there is your residual. I mean, your best fit line. So now the blue values are right here. And you take your pink or your magenta and you put a dot right there, 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 put a dot right there. You can actually see that the distances are very closer than these yellow distances right here. So I'm going to go over here and I'm going to say predicted points. And I'm going to punch that in. Equals negative 0.71 times x plus 114.9. Really? All right, copy that down. And those right there are your pink values. That's your predicted points. And now we're going to subtract. This is going to be called the residual. Well, I need to get it. Hold on a second. This is really a pain to do. I don't know why they keep making y'all do this. We're going to take the residual value and put it over here. So we're going to take equals the 91, and we're going to minus the 93. And that's going to give us our residual values. And then I'm going to square those. And add those up. And I'll be willing to bet you that this one's going to be smaller than the first one. And that's telling you that the line of regression does a better job with 5 points than with 2 points. So with all of this work, they're trying to get you to understand that a regression line using 5 points is more accurate than using 2 points. And this is another example of the law of large numbers. You get out what you what?
Put in.
put in. If you are got a good work ethic and you pull a bunch of points, then your presentation and your prediction is going to be a whole lot better than if you half-ass it. So that's what they're trying to get you to see with the residuals. I'm going to do it on the TI now. Now that we got those points in, I'm going to do a line of regression. I'm going to erase this. So I'm going to clear, and I'm going to clear this and clear this and clear all these drawings. Oh, man, no, I'm not. I'm about ready to quit. All right. There we go. And I'm going to go over here to stat. Go to stat. Calculate. Linear regression. And that'll read L1 and L2. And there is your y is equal to negative 0.71x plus 114.9. Now, the good thing with the calculator is you can calculate everything without having to punch in anything or punch in a lot of numbers. So you go to stat, go to edit, and what are we supposed to do in L3? What are you supposed to do? You're supposed to get your residuals. So that is second, stat, go down to residuals, hit enter, and hit enter. There's your residuals. Those are your yellow lines. Now you're going to square both of those, square them. So go to L4, second, stat, L3, caret symbol, second power. And now to add all those up, stat, calculate, first variable statistic, second, 4, and calculate. And there, 33.3 is your summation of regression squared, or residual squared, 33.1. That should be what we got with the spreadsheet, 33.1. Okay, now that's about the second or third time I've done residuals. Does anybody have questions on it?
You said you're not going to test us on residuals, are you?
No, they're just homework questions. I'll test you on the stuff that I told you I'd test you on. Are the correlation coefficient, causality, the slope, and the equation, and the scatter plot, and whether you can put a line in the scatter plot. Okay? Now let's get back to chapter 5. How far did we get? Did we finish chapter 5 with the subsets or the sample spaces? Well, let's see. What is the probability of a couple having 3 children with 1 girl? 1 girl, at least 1 girl. So I'm going to say at least 1 girl. Now remember that, at least 1 girl, 3 children. At least 1. Your handy dandy, I don't know if I sent y'all. Did I send y'all the sample spaces? Yes or no?
Yes, sir.
I did. So let me look in the files and pull it up. I can't remember what I called them, but I'm looking for them. They're normal distribution. I don't see them.
I think you just titled it sample space.
Yeah, I don't think I sent them. I may have sent you a picture.
Yeah.
So I'll pull it up. Hold on. I'll pull up and send you the Word document. I know that only 2 of y'all is going to print it out, but it doesn't matter. I'll go ahead and send it. So give me a second to send it. I know I've got it in here somewhere. I think I called it. Give me a second. I'm finding it. Sample space. Oh, man. All right, somebody that's either got the lap tape. Well, it says I sent it. Yeah, I did send it. Oh, well, I'll pull it up. So you pull up your sample space, and it should have, if it ever does come up, and I'm waiting on it still. Okay, there's 3 children. So what does at least one girl mean? That means that the lowest number is what? 1. So the lowest number equals 1. So that means I can have 2, right? Or 3?
Yep.
So that means 7 out of what?
8.
7 out of 8. Now that question I will put on a test and people will get it wrong. Now why will they get it wrong? Because they get it confused with this question. What is the probability of 1 girl? So what is the probability of 1 girl?
That's 3 out of 8.
How many?
3 out of 8.
3 out of 8. Good. And the difference is this right here. At least. The difference is the word at least. So you get a totally different answer. How about probability of rolling a 7 on a pair of dice?
0.
Well, you just go to your handy dandy handout, but that 2 of you is going to print out. And you find 7. Let's see, where is 7? Well, there's 3 and 4. There's 2 and 5. There's 1 and 6. 4 and 3. 5 and 2. 6 and 1. So what's the probability? 6 out of 36, which is what?
1/6.
1/6. Now, why did I show you those 2 problems?
Because they're on the test.
Because they're on the test, they're very simple, and the only people that's going to miss them are the people that are too lazy to print out those handouts that I just sent you. Question. And that's 5.1. Difference in 5.1. Let me give you 3 more. What is the probability of a king in a deck of cards? Picking a king out of a deck of cards.
4 out of 52.
4 out of 52, which is what?
1/3. 13.
1 out of 13, decimal according, round the decimal according to instructions. What is the probability of an odd number on a die being rolled?
3 out of 6, so 1/2.
3 out of 6, which is equal to 0.5. And what is the probability of a 7 on a die being rolled?
0.
So you've got your individual probability, and then you've got your group probability, or your sample space probability. Question, gripe, complaint. Okay, then 5.2 and 5.3, let me move this out of the way. Hold on, I'm getting your page back the way it was. All right. Now, 5.2 and 5.3. Additive law. Multiplicative law. Okay. Keyword or, keyword and. In the question, at the end of the question, it will say, what is the probability of blank or blank? Or it will say, what is the probability of blank and blank? And means multiplicative. Or means additive. With the additive law, the only thing you have to look out for, and this is in red because it's important, always subtract the overlap. With the multiplicative law, the only thing you have to worry about is whether it's with replacement or without replacement. Without replacement means that if you draw a marble out of a bag, you put you record what color the marble is, and then you put the marble back in the bag. That's called with replacement. With replacement is independent. Without replacement is dependent. That's a test question. Make sure you know it. Now I'm going to show you an example of each, and the examples that I pick will be test questions. I'm going to go to another page because I want to put a page to each example. One of the best examples that I know of the additive law is blood types. Because you can do several of these as questions. You got a table, RH negative, RH positive, then you got A, B, AB, and O. And we've got 2, 4, 6, 8, 1, 3, 5, 7. Now, why is that? As the class goes on and on and on, that feedback gets worse and worse. And y'all can't hear it, right?
No, sir.
Think of yourself. You ever gone up to a drive-through? Okay, everybody knows where the Bojangles is in LA, right here down here, 20 bypass. You ever gone into that, gone through that line and the speaker talks back to you? You hear your echo in that speaker?
Yeah.
That's what it sounds like, and it's very annoying. All right.
Too fair that this is a Bojangles.
Too bad we can't have a Chick-fil-A, but West Anderson, West LA, West and South Anderson, we can't have things like that because they get shot up. All right. So here we go. I want to know the probability of getting A type blood or AB type blood. Now, does anybody know what the first step is with this? What's the first step in finding any probability? You got to find your denominator. How do you find the denominator here?
Add them all up.
Good, do that. Add them all up. Let's see, there's a 10 right here. There's a 10 right there. So there's 20, 25, 29. I got 36.
That's what I got.
So you put 36 on the bottom. So the probability of A, I'm going to take my highlighter and I'm going to highlight A in green. And I'm going to highlight AB in purple. Now the highlighter helps here. Now I realize that some of y'all are too important to use the highlighter because you invented this, but some of you might want to use it. So A is green and pink is AB. Now I want to ask you a question. Well, I'll just go ahead and do it. So I got 2 plus, because we're using the additive law, 11 minus the overlap. Can somebody tell me what the overlap is? Is there an overlap?
No.
No, so you put a 0 there.
Wouldn't
That's the overlap.
it be 3 plus 11? Because you got.
Yeah, thank you. Thank you.
Go.
Over 36. And now you just do the adding and you get 14 over 36. I'm not going to worry about the decimal and I'm not going to worry about simplifying. Y'all are in 12th, 11th, 12th, fixing to graduate. Y'all know to reduce that and to give you a decimal. I'm not going to do that. All right, now I want to do another one. Because this is one type test question you'll get. Now I'm going to do the chart again. Same chart, but I can't get rid of the highlights. So RH negative, RH positive, A, B, AB, and O. And 2, 4, 6, 8, 1, 3, 5, 7. And I want the probability of B or RH positive. Okay, I want y'all to do that one. See if you can do it. probability of B or RH positive. All right. So 4 plus 3 plus, since we're adding, 1 plus 3 plus 5 plus 7 minus the overlap. Can somebody tell me what the overlap is?
3.
Good job. And that's all you got to remember when you're doing additive law. So 4 plus 3. Now, yeah, you could say that the 3 cancels this 3 out right here and do it that way. And you get 4 plus 3, and I think we got 36. So that's 7 plus, well, 5 plus, that's 13.
Yes.
Y'all gonna have to check my math because I suck. Over 36. And that's going to be equal to 20 over 36. And simplify, change into decimal according to directions. And that's the 2 type questions you're going to get with the additive law. It's either going to not overlap or it's going to overlap. Kind of helps to have it in a table. So if you can take your data or your question and put it in a table, you'll see the overlap. Now, what about a golf bag? We're going to do a golf bag because when I say marble bag, some of y'all think I mean Marlboro, like in Marlboro Reds, and I'm not talking about Marlboro Reds. All right, so you got your golf bag, and you got your pouch right here, and that pouch has golf balls in it. And you've got 4 red golf balls. You've got 3 blue golf balls. And you've got 4 green golf balls. Now the question is going to ask, what is the probability of picking 4 golf balls in a row without replacement or with replacement, and all of them being red? Okay? Or 3 golf balls, you know. You want to, and I'm going to write the question up here. Drawing out 3 golf balls with replacement or independent. Remember to say either independent or with replacement, and all being red. All 3 being red. Now, somebody tell me about golf balls. I mean, about width replacement. Can somebody tell me what that means?
Who? Riley Simpson.
Ooh, she's in trouble.
It's,
There's
there's,
across from the
they
library.
moved it, they moved it.
Oh,
It's,
yeah,
don't go there.
They moved, why they moved his office?
Are you talking about Mr. Duckett?
Beside Mr. Roberts'
It's where
office.
Mr. Duckett. You in trouble, girl.
Riley's in trouble.
Lord, where's she going? She don't know
The,
where she's going?
he's like,
Discipline?
yeah, that's where you go when you're bad.
That's where you go when you get in trouble.
Riley said, look, Riley said one too many offensive things about me.
Okay, somebody tell me what width replacement means.
Width replacement means you put it back.
That means that you pull a golf ball out of the bag, you write down the color, and you put it back in the bag. When you put it back in the bag, do you change the math behind the golf balls?
Nope.
No, and that's what independent means. You do not change the future outcomes. That's why width replacement is called independent. So in this case, you just take, how many is our denominator? 19? I'm sorry, 4 is 8, 9, 10, 11. So our denominator is 11.
You have a work email.
And our red is 4. And the exponent, and I'm going to do that in another color. Let's go with a pink. Yeah, let's go with an orange. The exponent is always going to be what? What you're drawing out or what you're pulling out. 3 pulls, exponent of 3. Or you could do it like this. You could say 4 over 11 times 4 over 11 times 4 over 11. Because we are using the multiplicative law, so that's why you're picking a red and a red and a red and. So you take your handy dandy calculator, and that's going to be 16 over 121. And you put that in your calculator, and whatever decimal they want, that's your answer.
Wait,
Oh, I'm sorry. Not 16, 64. I'm thinking it's squared.
it's 60 over
What is it? 64 over what?
1,331.
1,331. Thank you. And put that into a decimal form. Now, that's not a problem because everybody understands this. Okay, everybody understands that you take if you draw 3 times, the exponent's going to be 3 because with replacement, the numbers are going to stay the same. But what about without replacement? Well, we're going to do the same thing. You got a bag that holds golf balls. You got 4 reds. You got 3 blues. And you got 4 greens. And let's say the question is the same, except drawing 3 reds without replacement. So the first one is going to be 4 over what? 11. Somebody tell me what the second draw is going to be, because you put that one in your pocket. What's the next one going to be?
3 over 10.
3 off for what?
10.
3 over 10, you put that in your pocket. And the next one,
2 over 9.
now I want somebody to calculate this one for us, and somebody to calculate and round it to 4 decimal places. Somebody calculate this first one for me. 64 over 1331 and give me 4 decimal points. 64 over 1331.
0.0480.
Everybody agree with that?
Yes, sir.
Now somebody do this and round 4 decimal places.
0.0242.
Jeez, what is he? I think nobody.
Are they different? Yes or no?
Yes.
They are different. So when does it not matter? I want you to write this down so you will know. After 3 digits or 300 and above, it doesn't matter which method you use. Write that down. After 3 digits or 300, in other words, 307. That's what we're fixing to do right now. We're going to change this bag. We're going to change this bag, and we're going to put 400, 300, and 400. So we're going to do another bag. And this bag is going to have 400 red golf balls, 300 blue golf balls, and 400 green golf balls. Now I want you to pick 3 reds. Draw, what is the probability of drawing 3 reds at a time? 3 at a time. Well, that's going to be what? 400 over what? 1100?
Yep.
Raised to the 3rd power. Somebody do that. Give me 4 digits, please. 400 cubed divided by 1100 cubed, and give me 4 digits, 4 decimal places.
0.0480.
0480. Now I want you to do 400 divided by 1100. You put 1 in your pocket. What's the next one?
399 divided by 1,900. Or wait, sorry.
1099, right?
Yeah.
And 398, I go over what?
1,098.
1098. Somebody multiply that, please. And give me 3 or 4 decimal points. I'm going to give you a second to do that. I would put it in parentheses and just do the whole thing as one operation. Parentheses, 400 over 11, close parentheses, times 399 over 1099, close parentheses, times 398 over 1098, close parentheses.
Okay, I got 0.04785.
89, which is 0.0480. Is there any difference between these two answers?
No.
Yes or no?
No.
I think I heard somebody say no. They're the same answer, aren't they?
There's there's no difference.
Yes. Why is it the same answer? You use two different methods. Because these numbers are above 3 digits or above 300. That's why. So after 300 or 3 digits, do you have to really care whether it's with or without replacement? No. I usually stay above 300. If it's above 300, that's usually a good number. You get the same answer. Everybody understand that?
Yes, sir.
Y'all are losing. I'm losing you. It's getting close to time to go, I know. So let's write down the important things we learned today about the additive and the additive law. The additive law, you have to remember one thing. Always subtract the what?
Overlap.
Always subtract the overlap. With the multiplicative law, you got to do a little bit more. You got to know whether it's with replacement, which is called independent, or without replacement. Which is called dependent. That's a test question. And after 300 and up, it really doesn't matter which method you use. Now, I want to say this. What if I have 100 golf balls, 300 golf balls, and 250 golf balls? Well, not all of them are above 300, so I would probably make sure I did it the way they said. I'm talking all the numbers are above 300. Usually 300 is a good number. 300 and above, it doesn't matter. But if one of those numbers, if one of your quantities or two of your quantities is below 300, then you might see a little bit of difference in the third and the fourth decimal place. Okay? Who's got questions here? And I don't know, somebody look, let me look in your, I'm going to look right quick. I wish they'd get y'all some earphones and do this the way everybody else is doing it. It'd make things a whole lot better. All right. Here is the outline. Who was that? Somebody just came in.
Hey, it's
Hey.
I was gonna let you finish class, and then I was gonna talk to them about the setup for next class, or really talk to you too.
Well, that'll be fine. I'm just going to tell them this one thing. Here you are. There's 5.2, the addition rule, and 5.3, the multiplicative rule. Remember I told you we wasn't going over 5.4. So unless I change my mind, don't worry about 5.4, but work on 5.2 and 5.3. How many people we got in the room? Is all 15 in the room?
Yes, all 15 are here.
Okay, then that means I can just let them go. You go right ahead. Let me cut off the recording, and y'all can go, and I'll stay and talk to whoever I need to talk to.
Okay. All right, guys.